Oh, hello! I can see you there. I was just enjoying this universe-shaped donut. Oh, it just looks like a regular donut to you. Well, you're right about that. But it might just also be the shape of our universe. Let's back up a bit. Now, when we talk about the shape of the universe, there are actually only three possibilities. Positively curved, like a sphere, negatively curved, like a saddle, or flat. This can be a little confusing. How could a universe be flat when we live in 3 dimensions? Well, to answer that, we'll first have to define flat. Let's say you draw a triangle on a sheet of paper. The angles of that triangle add up to 180 degrees, right? But if you try to draw a triangle on a ball, suddenly the angles are way bigger. Now they add up to more than 180 degrees. Similarly, if you draw a triangle on a Pringle chip, the angles are less than 180 degrees. Now Euclidean geometry, which is the geometry you learned in high school, doesn't work. We can apply these same attributes to space, so what we really mean when we say that space is flat is that space conforms to Euclidean geometry. But why does space have curvature? Well, thanks to Einstein's theory of general relativity, we know that massive objects distort spacetime, so the shape of the universe depends on its density. If there's a lot of matter on average in a universe, then it'll have an overall positive curvature. This is called a closed universe. On the other hand, if there's not a lot of matter in a universe, then it'll have an overall negative curvature and be an open universe. In a truly cosmic coincidence, most of the evidence right now points to our universe having just the right density to have almost no curvature at all, making our universe flat. Now we can go back to the donut. We've established that when we say the shape of our universe is flat, what we really mean is that it conforms to Euclidean geometry. Triangles have 180 degrees, and high school math works. But that doesn't necessarily mean that our universe is a plane. The topology of the universe, that is to say, how it actually looks, has many different possibilities. Imagine rolling a flat sheet of paper into a tube. Now imagine bending that tube into a donut shape, or a torus. You can't do this in real life, but topologically, the torus is the same as the sheet of paper, meaning it's also flat. On average, the torus has no curvature. The negative curvature of the inside cancels out the positive curvature of the outside. There are lots of other examples of similar shapes, which are flat but not planes, such as Mobius strips and Klein bottles. Our universe could be shaped like any of these. One thing's for sure though, a donut-shaped universe is definitely the most delicious option.